Today I'm going to share a perspective on code collaboration. But before I dive into it, let me briefly introduce myself. My name is Kiril. I am based in Stockholm, Sweden, and I'm personally deeply interested in developer tools. I used to work with tooling and productivity at a large company before, and now I'm a co-founder of Sturdy, where we are only focused on developer tools. I would like to start by adding some context here. So, DevOps and continuous delivery have grown hugely in popularity over the past few years. In fact, this is the most practiced methodology out there. And what does this mean? At the center of continuous delivery is this idea of shipping small incremental changes more frequently. And this is very beneficial because small code changes, they're easier to reason around, they're easier to review, and they're also less risky to ship. You know exactly what has changed at a given time. And on top of that, there is this great benefit that it helps boost the velocity within a team. So DevOps research done at Google actually considers lead time, that is the wait time before your code hits production, as well as the deployment frequency as key performance indicators. And then there is an observation to be made from their data. More and more teams are shipping more and more frequently. So what you're seeing is the percentage of teams deploying code multiple times a day. And you can see that this has tripled over the past 3 years. Okay, so shipping small and often is great, but what is stopping us from merging, say, 30 pull requests per day? And of course, I'm talking here about breaking down the same amount of work into smaller chunks and shipping it incrementally. Well, there is some fixed overhead to a code contribution. For example, there is the creation of a branch, making a commit, pulling and pushing code. With more contributions, this fixed overhead is greater as a proportion. And there is, of course, some overhead associated with reviewing of that code. That's both as an author, but as well also as that is true as an author, but also as a reviewer. Now, there is an effort associated with communicating clearly your intent and context. As a reviewer, dealing with this many pull requests can really disrupt your own workflow. Let's look at some data from GitHub. This is the median time, lead time for getting a review of a piece of code. So I would say 5 hours is quite a long time. And this is just the median. It doesn't consider those more difficult pull requests that require more time, or all the cases where a developer is busy and cannot provide a review at a particular time. And there's another thing to note here, which is that the lead time for review at work is about half as long as that in open source. But we'll get back to this in a second. So all of this raises the question, why do we do code reviews in the first place? Well, it's a process that we as an industry have put in place in order to improve the code quality and prevent bad things from happening in production, catching bugs before they're out. Also, we are using code reviews as a mechanism for exchanging feedback early before the change is accepted. It's an opportunity to discuss code, suggest different ways of doing things. Taking this a step further is knowledge sharing. So good reviews can be a great opportunity for asynchronously sharing knowledge or sharing ways of doing things or showing to each other different techniques. And in some cases, code review is part of compliance. We just have to have it to tick that compliance box. I would like to note that, as you see, we use reviews as two separate things. We use it for quality gating, blocking, and also for collaboration. But they are distinct concepts. I would like to discuss some of the costs of formal reviews. As everything in software engineering, there are trade-offs. So firstly, while waiting for review, you're blocked from progressing further. That is just the nature of formal review or being blocked. You can, of course, choose to work on something else, pick another task, and then come back to this later. But of course, we know that there is cost to context switching as well. So another strategy here is, as a developer, you can continue working in another branch that is based on the work which is currently under review. But of course, when you do that, you need to manage the order in which different chunks of code are reviewed and subsequently merged, as well as you need to rebase as you make changes in earlier pull requests. Another trade-off of formal reviews is that the feedback that we get typically comes late in the process. So review implies a formal process in most cases. And naturally, as developers, we want the code to be complete, to be ready, to be as close to perfect as possible before we ask for feedback or review. But the thing is, at that point, our solution is less moldable. We are less susceptible to, let's say, feedback or suggestion for trying a different design or approach. We can mitigate this by putting a conscious effort to push chunks of code early and proactively trying to ask each other for feedback. But that's not the default. That is requires conscious effort. And there's another thing. With pull requests, there's this tendencies for them to grow in size and scope over time. So the path of least resistance is to keep adding things or keep adding fixes. And to keep it small, we need to actively put effort into this. Like you've probably heard in some teams, this saying of, okay, let's keep pull requests under certain size so that it's easier to review. And the thing is, giving a review really gets much harder as the pull request gets larger. So this is because it's simply harder to digest, harder to understand what the contribution is trying to achieve. And then there is an interesting observation here. At a certain level of size or complexity of a contribution, as reviewers, we just give up and say, okay, looks good to me. At that point, the lead time or the time that we wait for review drops just because we've lifted our hands. An interesting point to make here is that pull requests were made for open source development, and that is different from how we work. In open source, we're taking contributions from many people that we know do not know, from all over the world, perhaps. It is, in a sense, a solution made for a low trust environment. At the same time, we're using this tool at work as well, where within the team, we're highly aligned. We do stand-ups every day. We know what everybody on the team is working on. We plan together. We set our goals and milestones together. So with this process that we've introduced, surely we caught some of the bugs, but the question is it worth it? Or is the cost worth so much formality? And the broader community is beginning to fundamentally question code reviews and, by extension, the pull request workflow. These conversations are heated, to say the least, and a major question that arises in those conversations is, okay, if we don't do code review, what about collaboration? When do we exchange feedback? When do we give suggestions to one another? Well, for some teams, pair or mob programming is that alternative. This simply means working very closely together in a pair or in a mob, where we solve the same problem, and in most cases, it's one person typing and another person kind of co-piloting or helping out. This process has the exact same goals as code review. We want to improve quality, we want to catch bugs before they reach production, and we want to share knowledge, we want to grow as a team, share techniques and different ways of doing things. When we work that closely together, there are some extra benefits. And for one, that's the immediate feedback. So as we are problem solving, we are right there in the moment, having that conversation on the problem or on the solution. And the really exciting thing is the fact that this allows for compounding of ideas. So if one developer has an idea, the other developer can build on top of that, and together they come up with something even greater. It's in a sense pooling of that knowledge within the team. And this is why this process is widely regarded as very, very efficient at getting stuff done actually quickly. And because you already have multiple pairs of eyes looking at the problem, and you can say those eyes have looked even deeper than standard review, there is no more need for additional process. The code is considered automatically reviewed or reviewed by default. But of course, again, in engineering, there are trade-offs to everything. So what are some trade-offs associated with pair programming? I would say the main trade-off and the main point that folks are raising when they discuss this approach is the fact that this process is inherently synchronous. That means that you are there as a pair or as a mob, and you have to be in the moment problem solving. You lose that flexibility of thinking about the problem at your own time or whenever it fits the individual. You can also make the argument that this way of working reduces the multitasking ability of a team. That is, you have less things ongoing in parallel. And finally, it's important to highlight that this way of working is just not for everybody. For instance, developers simply think or work at different cadences. A big question that I've been wondering is there a third option? An option which takes the best aspects of code review, pull requests, and pair programming. That means taking the early feedback and the ability to compound ideas that you have in pairing, together with the asynchronicity and the ability to contribute whenever it fits the team and the individual. Can we have both of these at the same time? I would like to share with you an idea for a workflow that meets these requirements, and that is working in the open. But what does that mean? It means that work in progress code is discoverable within the team. I can see what others in the team are working on, and they can see what I'm working on at the same time. It also means that work in progress is interactive. I can try somebody's code, I can suggest ideas, and also they can do the same with the code that I'm working on as well. This opens up the opportunity for really proactive feedback rather than reactive. In spirit, this concept is very, very similar to pair programming. In fact, this is exactly what we do when we pair. Everybody on the team sees the code as it evolves. However, the main difference here is that collaboration can still be asynchronous. So folks can work on their own ideas in isolation, and feedback can proactively come or reactively, as requested, come from within the team. Okay, how can we actually achieve working in the open? Well, firstly, the main goal here is enabling that early feedback or the ability to exchange ideas early on in the development process. For this to work, we need some tooling. Tooling can help with code sharing. And for this to work, code sharing needs to be automatic. It needs to be fast. It cannot disrupt development. And also, we need as a team to have an overview of the code within the team. And then taking this to the feedback aspect of things, we need as a team the ability to try each other's code, that code that is life changing. We need the ability to help each other, and it of course needs to be non-disruptive. It needs to preserve this property of asynchronicity. But doing this has a massive opportunity. So working in this way opens a massive opportunity for lowering the lead times. This is because when everything goes well, you've already seen the code within your team. You've already had that opportunity to exchange feedback. You've already suggested the ideas that you had. And when the code is ready, it's already been reviewed. In a sense, this is similar to pair programming. At the same time, you've allowed the opportunity to work asynchronously, something that is so important in this remote world today. And by lowering the lead time, it means as a team, you can release much more frequently per day. This is how you achieve a high number of deploys or releases every day. We wanted this workflow badly, so we built it. We built Sturdy. So I will briefly tell you a little bit about Sturdy. It's a version control platform. So this is where you collaborate as a team. It works through live coding, or it supports the ability of sharing that code and work in progress as it happens. It operates at a higher level than tools that are today. This way, reducing that overhead of making a contribution, making it very easy to make a small chunk and share with the rest of the team. And of course, as a developer tool, Sturdy is open source. You can run Sturdy either in the cloud or you can host it yourself, up to a team to decide. Thank you very much for listening. My name is Kiril. You can read more about Sturdy on our website, and you can follow me on Twitter if you'd like. Thank you very much.